Hello there, Year 10 mathematicians, Mr. Herman here, and this video will be a review of index laws. The learning goals for this video is to know that powers are used as a shorthand way of writing repeated multiplications, which we'll look into different examples for that. To understand that index laws for multiplication and division apply only to common bases, and to know how to combine powers with the same base under multiplication and division. The success criteria is you should be able to write a product in index form, to be able to interpret the base and index to write in expanded form, to be able to multiply terms with the same base by adding the powers, and to be able to divide terms with the same base by subtracting powers. Now, a lot of that terminology seems quite new, so we have to look into the basics. When we look into a question that looks like this, 2 times 2, we know the answer is 4, but we also know that this can be, in shorthand notation, be written as this. This 2 here is called the base number. This is the base. And this number that's on the top is called a power, or an indice, or an exponent. There's different names for it, depending on the context. This 2 here, this power, is dictated by however many times the base number is being multiplied. So for example, if I were to do 3 times 3 times 3 times 3, this is equal to the base, which is 3, to the power of 4, because there are 4 lots of this 3 here being multiplied. Now remember, it can only work with multiplication. If it's being added, you don't use this power or indice notation, okay? And this also works for letters as well. So if I were to have b times b times b, this is equal to the b, which is the base, to the power of 3, okay? Now, we'll be looking at all the different index laws. There's 5 of them. We'll be looking at every single one except for 4. So this is taken straight out of the textbook, and it has all the different laws here. When we are multiplying any of the bases that are the same by 2 different numbers, you just add those numbers together, m and n together, as your power, okay? And so that works with the first example here. So when we look at this example, simplify the following using the first index law. This is x to the power 5 times x to the power 4. Now I'm going to write the extended version out. X to the power 5 is x times x times x times x times x, because there's 5 of them. And this is being multiplied by 4 lots of them, x times x times x times x. And you can count out 1, 2, 3, 4, 5, 6, 7, 8, 9. This is x to the power of 9. But we don't need to write this out in the expanded format. All we can simply do is, because we know the powers of both of them, we can just add those powers together, as 5 plus 4 is equal to 9. Now this can also work for a bit more complicated questions like this. Just remember that this is 3 times a to the power 2 times b times 4 times a times b to the power 3. What you want to do is you want to break this down into the 3 different sections. 1 for the number and the other 2 for the letters. So 3 times 4, we know 3 times 4 to be 12. We've got a to the power of 2 times a. Now remember that a is also just a to the power of 1. There's 1 lot of them. And so there's technically a 1 there. And all we do is just add those powers, just like in the previous example. So 2 plus 1 is 3. So this is a to the power 3. And again, b to the power 1 times b to the power 3. Add the powers, this is b to the power 4. And it's as simple as that. The next example looks at the second law, and when there is a division that's involved, all you simply do is subtract the powers, which is the opposite of the first index law of adding the powers. So in this case, the bases are the same, so your answer is going to equal m, and 7, m to the power 7 divided by m to the power 5. As the base is the same, it's 7 minus 5 for the power, and this is just 2, okay? And B, this one is a little bit trickier because now we've got numbers involved. So I'll look at the number one afterwards. We'll first focus on what we can do for the letters. We've got x to the power 2 divided by x to the power of 1, because there is an invisible 1. So 2 minus 1 is 1. So x to the power 1, or just x by itself. Y to the power of 5 divided by y to the power of 2. 5 minus 2 is just 3. So it's y to the power of 3. Now we'll look into the number section, and we have 4 divided by 8. If you look at this in a number version, just like this, 4 divided by 8, if I have 4 items of something and I split it into 8 parts, I should be left with 0.5 or half. Okay, so 4 divided by 8 is half. We prefer this fraction format, okay? So the 1 goes on the top and the 2 goes on the bottom. But remember, whenever there's a fraction of some sort and we have letters involved, we don't necessarily need to write that 1. So my final answer is x times y to the power 3 all over 2. Okay, so the number part can be a bit tricky. Another way of knowing is finding the highest common factor that goes in between 4 and 8. This is just the same as half as well. Okay, there are different ways of working that one out. Question, example 12 from the textbook. We're going to now be looking at when there are powers out of a bracket within a base and another power. Okay, all this is saying is this is a to the power of 3 multiplied by itself 4 times. So a to the power 3 times a to the power 3 times a to the power 3 times a to the power 3. And all we do is just simply add those bases together, not bases together, the powers, sorry, together. So the base is going to be a, 3, 6, 9, 12. Now we can jump from this step straight to this step here whenever you have an exponent here and then another exponent outside. All you got to do is just multiply those exponents. And that you can see with law 3. Okay, so an m and n are just 2 different numbers. You just multiply them together when the bracket is on the outside. When the bracket is on the outside, when the power is on the outside of the bracket. Okay. So with B, this one here, we'll be looking at this 3 2y5 times 2y5 times 2y5. Now, I know that I said you could just get this power and multiply it into the inside. You got to be careful because there's also this 2 that's being applied to it as well. You're not just going to apply that power 3 to that 5, but also to that 2 here as well. So 2 times 2 times 2, 2 times 2 is 4, and then 4 times 2 is 8. So this is going to be equal to 8. And y to the power 5, y to the power 5, y to the power 5. Add those powers, you should get y to the power 15. And that's where that 5 times 3 comes from. But I wanted to show you the expanded format because that 3 is also applied to that base 2 as well. Okay? Because that 8, that 2 to the power 3 is also 8. And you can see that 3 being applied to it here. For C, we'll be looking at this power is going to be applied to every single number and base that's associated with it. And we could just jump straight to the final answer. So 3 to the power of 3, so that 3 is being applied to that one first. So 3 times 3 is 9, times 3 again is 27. X to the power 2 with the 3 there, this is x to the power of 6, as 2 times 3 is equal to 6. 3 to the 5, so 5 times 5 is 25, plus times another 5 is 125. Y squared with the 3, so that would be y to the power 6. And then z, that's just by itself, will be z to the power 3. Because that technically is a 1 there, so 1 times 3 is 3. Now, final one, a bit complicated, but there's going to be a little bit of tidy up for this one. So, we have a 3 that's on the outside, so it's not being applied to that power that's outside the bracket. So we'll leave the 3 like this. X to the power 3, y to the power 2 with the 3 on the outside, so that's y to the power 6. So 2 times 3 is 6. 4, x to the power 4 y squared. Nothing's being applied to that. There's no bracket on the outside, so we'll just leave it as is. And then this one here, 8x squared y. Now, let's put this line down here. We can see x is on the top and x is on the bottom. And remember, a fraction line also means divided by. So we're going to be applying the index law 2 when it comes to the division. But first, let's see if we can add all these up first. We've got a 3 and a 4. Let's do the numbers together. Put that in different colors. We know that this is a number 12. Alright, so we've got the 12. x3 times x4, so we add those powers, x7. y6 and y2 will just be y8, all over 8 x2 and y. Now the last part, let's ignore the number for now. We've got x7 divided by x2, so 7 take away 2, we've got the x5. y8 divided by y1, so that's just going to be y7, as 8 minus 1 is 7. And 12 over 8 can be simplified. 4 is the highest common factor that goes into both 12 and 8. So 4 goes into 12 3 times, and 4 goes into 8 2 times. And there's your final answer. So you see here, this almost gets eliminated from the bottom part here because of what's happening from the top. Okay, but as a result, these top powers change because of it. Okay, a lot of letters involved, obviously, but it's all very, very process-based. The last one, evaluate using the 0 power. Any number or letter that is to the power of 0 is equal to 1. So this right here is 4 times a to the power 0. And we know any number to the power 0 is equal to 1. So this is 4 times 1, which is equal to 4. And the last one here, this is 2 times p to the power 0 is 1 plus, now because this 3p is in the bracket, all of this will be to the power of 1, okay? In this case, there was no bracket from 2, so we kept it as a separate entity. But here, this is all just 1, okay? Because it's to the power 0. 2 times 1 is 2, plus that 1 gives us 3. And that concludes this video. I'll see you in the next one. Bye-bye.